All right, we're going to continue on with solving by factoring, solving a quadratic equation by factoring. So we are going to, let's just say down here that it's practice. Let's add some more practice. Oh my gosh, what is wrong with me? My E looked weird in my screen. Anyway, continuing on. All right, so we're practicing today. We're going to add a little bit more difficulty. So let's review. Again, remember that we're dealing with quadratics, where the largest exponent is 2. They need to be written in standard form. Today, maybe we're going to have to rewrite it in standard form. We're going to have to do some manipulation. Okay, so maybe this is going to come into play today. Also that the equation must be equal 0. And today we're going to add in some solving for 0, so we might have to move some stuff around to make it work. But again, it's going to be the same skill set of what we have been working through. And we might start incorporating a little bit different type of factoring in there, but for the most part, we're going to be sticking to these skills, and we're going to be adding some more skills on top of it in later sets of notes. So let's do, I don't have this page numbered, 106. All right, so let's just title it practice. All right, so we are, let's do one where I have to solve. Why not, right? All right, so let's do x squared plus 4x equals 21. So this is a familiar problem. In fact, it was on our previous page of notes, but the difference is that this problem does not equal 0. Right, so we have to make this problem equal 0. And to make this problem equal 0, I'm going to take this 21, and I'm going to move it to the other side of the equal sign. So meaning I'm going to subtract 21 from both sides. So I'm going to subtract 21 here, and I'm going to subtract 21 here. X squared plus 4x minus 21 equals 0. That's all I need to do. Now my problem is equal to 0. It's a quadratic, has the largest exponent of 2. In fact, this is a simple trinomial, so I can factor this, and I can continue to go on. So this is a simple one, so I'm looking for factors of negative 21 that have a sum of 4. So what times what makes negative 21? But when I add them together, I get positive 4. I'm going to have 7 and negative 3. So my factoring is x plus 7 and x minus 3 and is equal to 0. I solve each binomial. Don't miss the problem because you screwed up a simple one-step equation, right? And x equals 3. My answers, negative 7, 0, and 3, 0. All I had to do was make sure that it equaled 0. And because it did not equal 0, it equaled 21, I had to do some math behind it to get it to equal 0. So I had to take that 21 and I had to move it to the other side of the equation. 21 minus 21, now my problem equals 0. Let's do another one. Let's do what color do I want to do? Let's do pink. Let's do 3x squared plus 14x. Oh, no, you know what? I'm going to rewrite that. I'm going to do 3x squared equals negative 14x plus 5. So I want my problem to equal 0. So I've got two choices. I could move both of these pieces over to this side, or I can move this one piece over to this side. It's your choice. I'm going to just move one piece just because that sounds a little bit easier to me. I'm going to subtract 3x squared from both sides. Remember, these are not like terms over here. They do not combine. So my problem is going to be 0 equals negative 3x squared minus 4x plus 5. Now I have a problem. I have a leading coefficient that's negative. I need to take that negative out. So I'm going to rewrite my problem as 0 equals negative 1. That becomes positive. This becomes positive. And this becomes negative. This negative, however, is no longer going to impact my answer to my problem at the end. But you can draw an arrow, draw it down so that I remember to bring it down. So I have an A and a C value. So now I'm looking for factors of 3 times negative 5, which is negative 15, that have a sum of positive 14. So what times what makes negative 15? 3 and 5? But I can't get 14 from 3 and 5. What times what makes negative 15 but positive 14? Ooh, I got it. Negative 15 and positive 1. Negative 15 times positive 1 is negative 15, but negative 15 plus, oh, no, this one needs to be positive, and this one needs to be negative. 15 and negative 1 make negative 15. 15 and negative minus 1 is 14. Perfect. So I'm going to replace my middle term. 3x squared plus 15x minus 1x minus 5. Split it in half is positive 5. And that's a negative 1 x plus 5. So my answer, my factorization, is 3x minus 1 and x plus 5. I had a negative 1 at the beginning that I factored out, and this equals 0. This negative 1, though, is not going to impact how I solve for my problem. I factored it. The factoring skill is not new. The new part is now taking each of the factors, 3x minus 1 equals 0, and x plus 5 equals 0, and solving. Plus 1, 3x equals 1 over, no, 1. Divide by 3, divide by 3, I got ahead of myself. X equals 1/3. Over here, I'm going to subtract by 5, subtract by 5. X equals negative 5. So my answers are 1/3, comma 0, and negative 5, comma 0. So today we're adding in that element of maybe instead of it already equaling 0 or it already equaling y, maybe I have to move something to get it to equal 0. And if I move those, right, I use inverse operations to move that value, it now equals 0. I can factor it and I can solve each binomial to write my ordered pairs. Again, my y value was always 0. Let's do one more, just for fun. And mainly because I just can't hear you yelling no at me anymore in class, which is let's do this one. Let's go back. Remember when we had these problems? Remember when we had a difference, a subtraction problem, and both of them were perfect squares. I mean, I could even throw a perfect square here, right? How do you get 4x squared, 2x and 2x? And how do you get negative 49, 7 and negative 7? So my factors for this problem are 2x plus 7 and 2x minus 7 equals 0. That was a couple units ago, but still remember, like, it's a perfect square and a perfect square. If this was a plus sign, we wouldn't be able to do it. Or if this said plus 40, I wouldn't be able to do it because I have to have a perfect square and a perfect square. And then I solve each one. 2x plus 7 equals 0. And 2x minus 7 equals 0. Minus 7, 2x equals negative 7, divide by 2, divide by 2. You could write it as a decimal, you could keep it as a fraction, doesn't matter to me. Dividing by 2 isn't that terrible. So I could do x equals negative 3.5. Over here, plus 7, 2x equals 7. Divided by 2, x equals positive 3.5. So this one, my answers are negative 3.5, comma 0 and 3.5, comma 0. Your factoring, still the same. Today, the additional layer is maybe it doesn't equal 0, like up here. Maybe it doesn't equal 0. Maybe it doesn't equal 0. So you have to make it equal 0 using inverse operations. Once it equals 0, you factor it like we've been practicing. And when you get your answer, our answers right now are 2 binomials. When you get these 2 binomials, you solve each binomial. And then write your answer as an ordered pair.